Hello and welcome to the next video. We are moving on from working inside of tables to knowing the rules for working with the means and standard deviations once they've been manipulated. So this is sort of similar to something we did back in chapter 3 or chapter 4. It might even be in chapter 5, where when you add a constant to the mean, you would add it. But when you add a constant to the standard deviation, okay, it doesn't add to the standard deviation. Okay, so that was something we learned in the past, but this stuff's a little more complicated, but not too bad. I just remembered I was going to type this. I wasn't going to write. Okay, so what happens? Expected value of capital X. Okay, and plus or minus some constant. Okay, so this means that I'm adding or subtracting a constant to the mean at the end after I find it. Okay, so all we would do is we'd take the expected value of x, okay, and we would add or subtract that constant. Okay, so and I'm gonna write these out, and then I'm gonna do another video on explaining explaining what they mean. Okay, so if you notice over here, let me show you. If you notice over here, I write variance. Okay, but in reality, we're going to be wanting to find our standard deviation. So to find our standard deviation, we always have to go through variance first, because the variance is the standard deviation squared. Okay, so you can't find the standard deviation and square it. You have to find the variance and then take the square root of it. It's very important. If they ask you to find the standard deviation, you always start with the variance. Okay, so we learned this before. You said the variance of x plus or minus some constant. Okay, that just equals the variance of x. Okay, so you do not add or subtract a constant to the variance. Okay, it's very important. We've actually learned that before. I'll just show you real quickly kind of why, but you remember the standard deviation and the IQR, okay, are both measures of spread. So you could look at it the same way. Or I could do it on a graph like this. So say these were the heights. Okay, these were the heights of the men, and the standard deviation, that's the negative standard deviation. This is the positive standard deviation. Okay, so let's say I add 5 to everybody. Now this is the standard deviation right there, right? So if I add 5 to everybody, this whole thing is just going to shift this way by 5. But did this distance right here change? Did that distance right here change? No, it's just this shifts over 5 and that shifts over 5. So it's the same standard deviation. Okay, so that's kind of one of the reasons why we don't do that. Okay, so I will show you examples later. Okay, rules for multiplying a constant, okay, to the expected value, which is the mean of the random variable, and the variance. And a lot of these you'll see. So this is the expected value of some constant times the random variable. Okay, this equals whatever that constant was times the expected value of x. Okay, so if you multiply your standard deviation by a number, this is actually multiplying all your random variables by a number. Okay, you're increasing your random variations by a multiple of c. Okay, and that works that way. The variance is a little different, because remember, the variance is the variance is the standard deviation squared. Okay, so remember, we always do variance, So if that's c times, okay, this is going to be c squared. Okay, and I gotta put the squared in later. It's c, it's a times the variance of x. But this guy is squared. This c is squared. So let me just do that, and I'll add a little dot in there. C squared times the variance of x. Okay, this constant gets squared. Okay. All right. So let's talk about this. Is important. Let's talk about adding. Okay, adding and subtracting two independent random variables. Okay, and you'll get a whole bunch of practice at these. Let's go ahead and say you have the expected value of x plus or minus some variable y. Two random variables, you're adding or subtracting them. So if this is the case, we could just add or subtract these. Okay, this rule right here, I'm going to talk about this in the next video, but this would be like, well, if x is one person buying the policy, that policy that we did was $20 per person, right? $20 per person. If x is one person and y is another person, okay, they're expected to pay $40 because they're going to pay 20 for this person, and they're going to pay 20 per person. As long as this person has nothing to do with this person, they're independent, you could go. Okay. All right, you could add them. All right, so let's go and do the most tricky one. Now, the variance is a little more tricky. And this is, you have to pay special attention and really practice at these examples. Okay, so I'm going to say x plus or minus y equals the variance of x now watch what I do here, plus the variance of y. Let's look at the difference between this one and this one. Now if you look, I got a plus minus here, an equal sign, and a plus minus. Here I have a plus minus, an equal sign, but this is just a what? That's just a plus. And that's because if the definition of variability, the definition of the variance is how much variability you have. Okay, so if you have one random variable, okay, with a lot of variance, and you have another random variable with a lot of variance, and you're subtracting that variance, you can't subtract the two and get less variance. If you have variance in one distribution, in one probability table, and you have variance in another probability table, variance is kind of like mistakes, like errors. Okay, so you can't have a lot of mistakes in one probability table and a lot of error in another table and subtract them and get no error. That's just not going to happen. When you combine your variances, it always adds. It always adds. And they're gonna get you. I'm gonna do a whole bunch of examples, but they're gonna say find the standard deviation of this x variable minus this y variable. And people are gonna just go ahead and use this. Okay, but you can't. You have to start with the variance. Okay, you have to start with the variance. So if they give you standard deviations, the first thing you have to do is square them. Okay, change them into variances. It's square, add, square them, add, and then take the square root. Mathematically, it's the same thing as this theorem right here. Do you remember this theorem? If you have A, B, and C, okay, let's say I do this. Let's say I say this is 4 and this is 5. And I say find C. Do you do 4 plus 5? And then say this is 9? No, we don't do this. This is the Pythagorean theorem. It's a squared plus b squared equals c squared. So what's the first thing I have to do with this 4? I have to square that 4. What's the first thing I have to do with this 5? I square it. I square them. I add them. I wanted to make this a perfect one, so let me make this a perfect one. It's a 3, 4. So 4. Is it 7? No, it's not 7. It's not 4 plus 3. So you would, I'm just making this a perfect 90-degree triangle. So look, it's not a plus b equals c, it's a squared plus b squared equals c squared. So you have to square the 4, square the 3, so I get 16 plus 9, which is 25. But is that the answer here? Is it 25? No, after you get your answer, you have to turn around and take the square root of it. So it turns back into a 5. So that's what this is right here. This is the Pythagorean theorem of stats. It's one of the most missed concepts, especially this add-in. Okay, for example, I'll say, oh, the standard deviation of x, watch this, is 4. The standard deviation of y equals 4. And I stress this so much in my classes, and it still always happens. That's why I'm really making it out. And I'll say, find the standard deviation of x minus y. Okay, so we can't work with standard deviation, so I have to change these right off the bat to variances. Okay, so I would say find the variance of x and y first. Okay, and then when I find this, go ahead and take the square root of it. So people will say, oh, well, that must be the variance of x. Well, most people just say 4 minus 4 and get 0. But the variance of even using the formula, they'll say variance of x minus the variance of y. Well, the variance of x, if this is 4, it's 16, minus the variance of y is 16. So they say, oh, well, you have some variability in x, you have some variability in y, but when you combine them, you have no variability. Okay, and if you remember, this is why it doesn't make sense. What does no variability mean? No variability means every data has to be the same. So if I said something like this, 5, 5, 5, I took a sample of 1, 2, 3, 4, 5, 6 people, and they all came out to be 5. How much variability is there? There's none, because everybody was 5. Okay? But if you're taking a bunch of x's and combining them with a bunch of y's, everything's not going to be the same. That's why this needs to be a plus sign. Okay, so you would add these two. If you were really doing this problem, you get 32, and then you turn around and take the square root of 32, and that would be the standard deviation of that, the square root of 32. So, and also make sure that you understand that they have to be independent. If they're not independent random variables, then this doesn't work. But there's a very nice thing about when we're dealing with x and y's is that a lot of times we're dealing with people, and if you randomly pick people, they're independent of each other. Okay, so this person here would have nothing to do with this person. Okay, so those are the formulas. On the next one, I'm going to do some more better examples for these, and then we'll be done. All right, have a nice day.